So imagine you are sitting courtside at the NBA Finals.
Oh, man. Okay. The tension in the arena is just palpable.
Exactly, yeah. And on one side of the court, you have the reigning MVPs, right? The heavyweights, everyone completely expects to win.
Right. And in the tech world, these are the giants you hear about every single day.
Yeah, exactly. Models like GPT 5.5, Cloud Opus 4.7.
Hmm.
But then, right as the buzzer is about to sound, this totally unknown rookie from Shanghai just steps onto the court, steals the ball, and dunks emphatically on the MVPs.
It's wild. But on June 1st, 2026, a startup named MiniMax did exactly that.
They really did. They dropped their M3 model, and I mean, the economics of artificial intelligence just changed overnight.
Literally overnight.
Right. Okay, let's unpack this, because how does a startup just, come out of nowhere
Yeah.
and challenge the established titans of AI?
Well, it is basically the defining question of the industry right now, largely because M3 isn't just a slight incremental improvement.
Right. It's not just a small bump in the stats.
Yeah. Exactly. It is a frontier-level coding agent, and it's engineered from the ground up to handle incredibly complex continuous tasks. I mean, we are looking at a model with a 1 million token context window.
1 million tokens. That's just massive.
It is, and crucially, it possesses native multimodal capabilities.
Which means what exactly for the listener who might just be catching up?
So that means it processes text and images simultaneously, right from day one. It doesn't have to awkwardly translate one format into another first.
Wow. Okay, so 1 million tokens combined with native text and image processing, and it's optimized specifically for coding and agentic workflows.
Yeah, that's the core of it.
So to really understand why this rookie is a global game changer, we first need to look at the raw numbers, right? Because Minimax released a stack of benchmark data for us to look at in this deep dive.
And the performance metrics are just staggering.
They really are. Like, let's look at SWE Bench Pro, which tests real-world software engineering capabilities. M3 scored 59%.
Right, and for you, the listener, it really helps to contextualize what 59% actually means on SWB Bench Pro.
Because it's not just a simple test, is it?
Oh no, this isn't a multiple choice trivia test at all. This benchmark hands an AI a real documented bug from a sprawling open source software repository on GitHub.
Like a real problem a human developer would face.
Exactly. And to score a point, the AI has to autonomously read the codebase, locate the flaw, write a custom patch, run tests to ensure it didn't break anything else, and then actually submit the final fix.
Wow.
Yeah. And M3 successfully completed that entire life cycle 59% of the time.
That is wild. I mean, that performance beats GPT 5.5.
It does.
It beats Gemini 3.1 Pro.
Mm.
And it is creeping dangerously close to the current industry ceilings set by Quad Opus 4.7.
Right. But what's fascinating here is that the disruption doesn't stop at just software engineering.
Oh, right. There's Terminal Bench 2.1.
Exactly. That tests how well an AI can operate a command line interface. M3 is hitting 66% on that.
Which is huge. But honestly, the most eye-opening metric in this entire stack of sources is browse comp. M3 scored 83.5%.
Yeah, that's the one that really turned heads.
I mean, that actually outperformed Claude Opus 4.7 in autonomous web navigation.
And, autonomous navigation is notoriously difficult for language models. The web is chaotic.
Very chaotic.
Right. Websites constantly change their layouts, pop-ups appear out of nowhere, and buttons are hidden under layers of complex code.
It's a mess.
It is. So to score an 83.5% on BrowseComp, M3 has to parse through all that visual and structural noise, make a decision on where to click, and keep moving toward a highly specific goal without getting stuck in a loop.
Handing an AI an 83.5% capability in autonomous navigation is basically the equivalent of handing it the keys to your car, dropping it in the middle of a major city, and trusting it to drive through rush hour traffic entirely on its own.
That's a great way to put it.
Like it has to navigate detours, read temporary road signs, and adjust to aggressive drivers without you ever touching the steering wheel. That level of adaptability is just wild.
It is wild, and that adaptability is exactly where the native multimodal architecture becomes so critical.
How so?
Well, when an AI can process images alongside text natively, it means it can literally see a user interface while it's reading the underlying code of the website.
Oh, I see.
Yeah, older models had to look at an image, generate a text description of that image, and then analyze the text.
Which takes forever.
Right, it was slow and really prone to errors. M3 doesn't do that translation step. It just understands the visual pixels and the textual code as one cohesive environment.
And it's doing all of this while holding an immense amount of information in its active memory.
Yeah.
I mean, you mentioned the 1 million token context window earlier.
Yeah, the scale there is hard to overstate.
Just for scale, that is a 5-fold increase from their previous model, the M2.7.
Huge jump.
A million tokens means you aren't just pasting a few snippets of code into a chat box. You can upload entire libraries of proprietary code bases, thousands of pages of dense documentation and, system architecture diagrams all at once.
But here's the catch with that. To maintain a million token window, you usually need billion-dollar server farms consuming the energy of a small city,
Right, the compute costs are usually insane.
Exactly. Processing that much data simultaneously is computationally exhausting, and MiniMax doesn't have the infinite compute budgets of the Western tech giants.
So they had to invent a workaround, right?
They did. They needed a way to process all that data without just melting their servers. Which brings us to the underlying engineering.
The engine room.
Right. The engine powering M3 is a proprietary architecture called MiniMax Sparse Attention, or MSA.
Yeah, the sources spend a lot of time on MSA. And to really understand why sparse attention is revolutionary, we need to look at the bottleneck it's designed to fix.
Oh, definitely.
Up until recently, most of the big language models relied on something called dense attention, right?
Right. So in a dense attention model, every single token, which is essentially a fragment of a word or code, has to mathematically connect and pay attention to every other token in the context window.
Which sounds incredibly inefficient.
It is. It creates a severe problem known as quadratic scaling. If you have 10 tokens, the model calculates 100 connections.
Okay.
But if you double your input to 20 tokens, the compute required doesn't just double to 200, it quadruples to 400.
Oh, wow. So if you scale that quadratic math up to a 1 million token context window, you are looking at 1 trillion mathematical connections for every single step the AI takes.
Exactly.
It's like being at a crowded cocktail party, and your brain is trying to actively listen to, process, and memorize every single conversation happening in the entire ballroom simultaneously.
That's the perfect analogy.
The cognitive load is overwhelming, the energy required is unsustainable, and eventually the system just crashes.
Right. So MiniMax implemented sparse attention to bypass that crash. Instead of forcing every token to look at every other token, MSA uses a subquadratic approach with dynamic block selection.
Dynamic block selection.
Yeah. The AI dynamically selects only the relevant blocks or chunks of information to pay attention to at any given microsecond, and it just ignores the rest.
Okay, but wait. If I am handing this AI 1 million tokens of my company's proprietary code, and it's actively skipping over entire chunks of it to save compute power, I have to wonder if it's missing the forest for the trees.
That's a fair point.
Does skipping data mean the AI is inherently cutting corners on quality?
It's a highly logical concern, and honestly, it's the exact hurdle researchers have been trying to clear for years. But the key phrase that prevents quality degradation is dynamic block selection.
So it's not just randomly dropping data.
No, not at all. The system isn't randomly ignoring data to save a quick buck. It utilizes lightweight routing networks to intelligently predict which blocks of text are actually relevant to the specific mathematical operation happening in that exact millisecond.
But how does a routing network predict what's relevant without actively reading the entire text first? That sounds like a paradox.
I know, it really does, but think of it like a highly skilled research librarian.
Okay.
A librarian doesn't need to read every single page of a million-word historical archive to find the answer to your highly specific question.
Right, they'd use the index.
Exactly. The librarian looks at the metadata, the chapter tags, the structural markers, the index headers. They use those high-level signals to dynamically route your question directly to page 402, completely skipping the 401 pages that just don't matter.
Oh, that makes so much sense. So the routing network acts as the librarian, pointing the AI's processing power only to the code snippets that actually matter for the current bug it's trying to fix.
Exactly. And furthermore, MSA builds heavily on an architectural concept called mixture of experts, or MOE.
Right, we've seen that pop up in a few sources.
Yeah, so instead of using the entire colossal brain of the AI for every single prompt, a MOE model contains several specialized mini-brains.
Oh, cool.
You might have one expert network highly trained on Python code, another trained on front-end visual interfaces, and another on mathematical logic. The router looks at your prompt and activates only the specific experts best equipped to handle it.
Leaving the rest of the system powered down.
Precise.
So by combining mixture of experts with dynamic block selection, the performance gains are sweeping. I mean, compared to their previous M2 model, This MSA architecture makes the pre-fill stage, which is the moment the model first ingests and comprehends your million token prompt 9.7 times faster.
Almost 10 times faster.
Yeah. And the decoding stage, which is when the model actually generates its response, is up to 15.6 times faster.
It's unbelievable. And by solving the architectural bottleneck of long context, MiniMax did more than just speed up a software product. They fundamentally altered the economics of artificial intelligence.
They really did.
Because it takes significantly less compute to run the model, it costs significantly less money to use the model. The pricing structure they've announced is sending shockwaves through the market.
Okay, here's where it gets really interesting.
Yeah.
Because we are talking roughly $0.12 and 2.6 cents per million input tokens, depending on which promotional tier you're looking at.
Right.
That is roughly 1/10 the cost of the top Western competitors. 1/10 the price for frontier-level performance.
Yeah, and that unprecedented price collapse completely redefines how you can actually integrate this technology into daily operations.
Because you don't have to worry about the bill as much.
Exactly. Because it's so cheap, you can utilize M3 in ways that would literally bankrupt a startup if they attempted the same workflows with GPT 5.5 or Opus 4.7. The research papers detail a real-world application where developers set M3 on a 24-hour autonomous execution loop.
Yes. And because of this pricing, the sources highlight a scenario where M3 ran thousands of tool calls autonomously to optimize incredibly complex CUDA kernels.
Which is not an easy task.
Not at all. For the listener, CUDA kernels are essentially the agonizing microscopic instructions that tell a graphics card exactly how to calculate data. Optimizing them is tedious, grueling work that usually takes human engineers weeks of trial and error.
Yeah, and previously, having an AI grind through thousands of iterations to optimize those kernels would rack up an astronomical server bill.
Oh, easily.
But at 12 cents a million tokens, the financial barrier just disappears. You can afford to let the machine run all night.
It's totally like hiring a tireless, genius-level intern who thrives on the night shift.
Ah, yeah, exactly.
You hand them a massive, tedious optimization problem at 5:00 p.m. before you log off. They sit in the dark, grinding through thousands of iterations, making microscopic code adjustments, running tests, failing, diagnosing the failure, and trying again.
But doing it over and over.
Right. They do all of this for just pennies. And when you wake up and pour your coffee the next morning, the perfectly optimized code is just sitting there in your inbox.
It's amazing. But if we connect this to the bigger picture, this hyper-efficient workflow, it becomes clear that MiniMax has very deliberate strategic goals.
What are they aiming for?
Well, first, they are aggressively moving to democratize frontier AI. They want to make top-tier capabilities accessible to solo developers and small businesses who previously just couldn't afford premium API access.
Makes sense.
Second, they are explicitly trying to dominate the lucrative coding agent segment of the market. And third, this launch perfectly coincides with their preparations for an initial public offering on Shanghai's Star Market.
The IPO. Releasing a frontier model at a 90% discount is certainly one way to flood the market with users, prove widespread adoption, and justify a colossal valuation to your future shareholders.
Definitely.
And they are making it highly accessible to ensure the adoption happens. You can access M3 via the MiniMax API. It's available on aggregator platforms like OpenRouter. And they are preparing to release open source weights to the public soon. They are pushing this out into the wild as fast as possible.
Yeah, and we must also impartially recognize the macroeconomic and geopolitical implications of this rollout. I mean, the sources touch on this.
We absolutely should.
For years, the prevailing narrative in Western tech circles was that China was simply a fast follower, copying Western AI advancements rather than originating them.
Right. That was the common thought.
But M3 shatters that assumption. MiniMax is actively driving global innovation and architectural efficiency. By doing so, they are forcing an international price war. When a competitor drops a frontier model at 1/10 the cost, established titans have no choice but to respond. It severely accelerates the commoditization of machine intelligence.
Unlimited, highly capable AI running complex tasks for pennies on the dollar sounds like a technological utopia. But in the world of frontier AI, nothing is flawless.
That's very true.
We need to look at the fine print and explore the caveats, because this deep dive wouldn't be complete without a reality check.
No, it wouldn't. And the first and most vital caveat revolves around the source of our data. Many of the staggering benchmarks we discussed earlier, like the 59% on SWE Bench Pro or the 83.5% on BrowseComp, are vendor-reported.
Oh, so MiniMax ran those tests themselves.
Exactly. And in the AI research community, independent verification is paramount.
Right, we can't just take their word for it.
No, we need to observe how M3 performs on neutral third-party evaluation platforms like artificial analysis or the LMSYS chatbot arena. We have to confirm these claims hold up under blind, randomized testing from everyday users.
The sources do note that early user reports are already highlighting some specific flaws.
They are, yeah.
While M3 is incredible at concrete coding tasks and executing direct commands, it apparently struggles with highly abstract reasoning. There are also specific coding leaderboards, like Deep SWE, where its performance dips, showing it doesn't perform quite as flawlessly across the board as it does on its preferred benchmarks.
And users have also reported a notable efficiency trade-off regarding the model's output. M3 is frequently described as verbose.
Gross.
Yeah, it tends to generate significantly more tokens than are strictly necessary to answer a prompt or write a requested function.
So what does this all mean for the economics we just praised? I mean, if the model is overly verbose and constantly spits out extra tokens, doesn't that inherently eat into the massive cost savings they promised?
It's a really good question.
If I'm paying per token, and the AI insists on writing a novel when I just ask for a simple script, that 1/10 price advantage starts shrinking, right?
Well, this raises an important question, but the reality is verbosity will certainly eat into your computational savings, but only marginally at these specific price points.
Because it's just so cheap to begin with.
Exactly. 12 cents a million tokens provides a lot of financial padding for overly chatty outputs. The true bottleneck caused by verbosity in coding agents is actually context bloat for the human operator.
Context bloat meaning the sheer volume of material a human has to review.
Precisely. If an autonomous agent writes 1,000 lines of code when it only needed 100 to solve the problem, that is 900 extra lines of potential failure point.
Oh, wow. Yeah.
More importantly, it is 900 extra lines of code that a human reviewer has to meticulously audit the next morning. The AI's time is cheap. The senior developer's time is incredibly expensive.
The transition from cheap AI generation to expensive human auditing brings up several macro challenges detailed in the source material. We have to impartially acknowledge the physical footprint of these systems, too.
We do.
Yes, the sparse attention architecture makes inference, the act of running the model cheaper and faster. But training a model of this caliber from scratch still requires colossal amounts of electricity, as well as millions of gallons of water to cool the data centers processing the initial data.
It's a massive environmental cost. And beyond the environmental footprint, the geopolitical landscape presents significant adoption hurdles.
How so?
Well, because MiniMax is a Shanghai-based startup, multinational corporations face complex dynamics regarding export restrictions and cross-border data privacy.
Oh, that makes sense.
Yeah. Western enterprise clients with strict compliance boards may be legally restricted or simply hesitant to integrate a foreign model into their core proprietary workflows, regardless of how cheap or capable the API is.
Right. And the final, and perhaps most pressing, challenge discussed in our sources revolves around the safety risks inherent to autonomous agents. This isn't unique to M3. It applies to any frontier model. But the risk is amplified here precisely because of the collapsed price point.
Amplified how?
Well, when you make it economically viable for anyone to spin up thousands of autonomous coding agents, you exponentially increase the system's level risk of an agent hallucinating.
Oh, absolutely. If an agent hallucinates a subtle vulnerability into a piece of back-end infrastructure and it's operating on a 24-hour loop, the damage can compound rapidly.
It's terrifying to think about.
It is. When agents are cheap enough to run completely unsupervised on the night shift, the critical need for robust safety guardrails becomes a huge engineering priority.
You suddenly need complex automated testing systems just to monitor the automated coding system.
Exactly. The blast radius for a hallucinated bug is significantly wider when the AI has the autonomy to execute code, interact with APIs, and navigate the web entirely on its own.
It is a profound balancing act. On one hand, you have unprecedented access to problem-solving power. On the other, unprecedented architectural risk if that power is left entirely unchecked by human oversight.
It's a lot to weigh.
It really is. So, to synthesize all of this for you, the listener, MiniMax M3 represents a sweeping paradigm shift. The core takeaway from this entire stack of research is that powerful tools for complex automation, native multimodal workflows, and advanced coding are no longer gatekept by premium, extensive subscriptions.
The monopoly on frontier intelligence has been fractured by architectural innovation.
Beautifully said.
Thanks. Whether you are a solo developer trying to build your first application, a massive enterprise looking to optimize your back-end infrastructure, or just a learner insanely curious about the mechanics of neural networks, the financial barrier to entry for building complex agentic workflows has just completely shattered.
It really has.
Yeah,
And it brings us full circle to that rookie stepping onto the court. The game has fundamentally changed.
it's a whole new ballgame.
Exactly. The established players are going to have to hustle to defend their market share against a competitor that processes faster, sees the digital world more clearly, and operates at a fraction of the cost.
Yeah.
Which leaves us with a final thought for you to mull over.
Oh, I like this.
If models like M3 make it economically viable to let an AI autonomously grind through thousands of complex coding iterations on the night shift, at what point does the human day shift get entirely reduced to just reviewing the work our AI colleagues completed while we were dreaming?
Wow. It is a profound shift in how we will measure the value of human labor in the knowledge economy.
It's definitely something to keep in mind the next time you log on for work in the morning and review the code waiting in your inbox. Thank you for joining us on this deep dive, and we'll catch you next time as we continue to unpack the frontier of technology.